In today's video, we will be talking about the next topic, which is character arrays and strings. So, before starting the video, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel Coders Arcade and press the bell icon so that you get notifications regarding our latest updates. Thank you. So let's get started. As I said, our today's topic is character arrays and strings. So let me start with the definition of a string. So a string can be defined as an array of characters, or we can also say that a string is a collection of characters. So as you can see in the screen, A is a character and it can be denoted like this inside quotes. B is also a character and it can be denoted like this inside quotes B. And if we have to define a string, then as I said earlier, string is a collection of characters. So here as you can see, H is a character and hi is a string inside quotes. So as I said, if we write a collection of characters inside quotes, this will be termed as a string. So let us see or learn how we can declare strings. So let us move on to the declaration part of strings. As you can see in the screen, the declaration can be like this: char string name followed by the length. Here char is the data type and then we have the name of the string followed by the length. And let me give you an example. Suppose char string name followed by inside square brackets 100. So this example represents a string of 100 characters. The length can be different depending on our choice. So as we know the declaration part, and as I have showed you in the figure, in case of strings we always use the character data type. So in the example you can see that we have used the character data type. Now after the declaration part, let us move on to the initialization part. So here there are two ways to initialize strings. The first way is using single character constant. Let us check an example so that I can tell you better about this topic. So here is the example. Char a of 10 is equal to inside curly braces hello, and just see how I have written the example. HELLO. All these individual characters are inside quotes and they are separated by commas. And finally at last we have /0 inside quotes. This /0 is known as the null character. This null character is actually a character which marks the end of the string. It tells the compiler that the string has ended. So this is the first way of initialization of strings. As I told you, it is using single character constant. Now let us move on to the second type of initialization of strings. The second type is using string constant. So let me show you another example so that you can understand the second type. The example is char a of 10 is equal to inside quotes hello. Here we are using a string constant. So in this case we do not have to use curly braces or we do not have to separate individual characters inside quotes. We can write the entire string inside quotes. So this type of initialization of strings is known as initialization using string constant. And please remember, in case of string constant, we do not use the null character because the null character is placed automatically by the compiler. We do not have to place it. So, after we have known about initialization of the strings, let us move on to the next topic, which is accessing of strings. So, as we already know from our previous videos, we can access integers with the help of %d. Similarly, we can access floats with the help of %f. In case of string also, we can use this method, which is %s. With the help of %s, we can access strings. So, as you know how to access strings, initiate strings and declare strings, let us move on to the editor so that I can show you a simple example with the help of which you can understand about strings more. So now I will be going on to my editor. Here I am inside my editor and now I will be writing the program for you. Let me write the header file, which is #include stdio.h. Then I will write my main function, and inside my main function I will write the data type for my string, which is char. Then I will take a of length, suppose 10. Then I will declare it as hello. Okay, and then I will give the semicolon. Then this will be a simple example so that I can show you how to print this string. Now I will use the printf statement and I will print the given string is %, as I told you earlier, it is s, and then I will give comma a and semicolon. So with the help of this, I can print the string. So let me run my program so that I can show you the output. I will run it for you now. So as you can see here, it prints the given string is hello. So this is how you can print it. But let me tell you one more thing. In this case, I am using the string constant. But I will also show you the other one, which is the single character constant. For that, I have to change the syntax a little bit. I will give a curly braces, and inside it, I will separate each character with the help of quotes. Let me show you how. I'm giving comma, and again I will give quotes. So with the help of quotes, we can separate each single character constant. And now let me show you one interesting thing. As I told you, the null character defines that the string has ended, and it tells the compiler this is the end of the string. Now let me assign the null character here, /0. So this is the null character. I will give a comma, and after that this O I will keep at last, as you can see here. So now, as I told you, this null character will actually tell the compiler that the string has ended. So when I print this, I get only 4 characters, which is H, E, L and L, because this null character will be the end of this and this O will not be printed. So let me just run the program so that I can show you the output. as you can see here, it says the given string is HELL. So as I told you, this null character will define the end of the string. Now if I put this O before this null character, and give a comma here, now you will see that hello will be printed. Let me run it. You can see here hello is printed. So this is how we can use single character constants or string constants, and we can print the strings. So this is a basic example. In today's video, we will be talking about the topic reading a series of words from a terminal using the scanf function. For this, we will be using arrays. So before starting the video, I would like to request you people to please like and share our videos, and also subscribe to our channel Coders Arcade and press the bell icon so that you can receive notifications about our latest updates. Also, share our videos with your friends and family and those who are willing to learn programming. So let's get started. As I told, today's topic is reading a series of words from a terminal using the scanf function. So let us directly go on to the editor so that I can show you the program. I am going to my editor now, and here I will start with the main function. So inside the main function, I will create my variables. So I will take the character data type, and then I will take the variables, say word1, and the size should be say 20. Similarly, I will take 4 or 3 other variables, word2 20, word3 20, and word4, the length is also 20 in this case. Then I will give the semicolon, and I have to remove this semicolon and give a comma here. So now I have declared the variables, which are arrays. Then here I will use the printf statement, and I will write enter the words one by one, and then I will give the /n so that I can go on to the next line. So here, to take the user input from the user and store it into the variables, which are word1, word2, word3, and word4, I have to use the scanf function. So let us use it, scanf. And now inside quotes, as I told you in my earlier video, to read the characters or the strings, actually we have to use %s, and then I will give a comma, and here I will call my word1 variable. Similarly, I will do it for the other ones as well. I will just copy this code, and then I will paste it 3 times. So here I just have to change it for word2, word3, and word4. Then after that, I will use a printf statement so that I can take the control to the next line. For that, I will use /n. So here I have to give a semicolon, and also in all the earlier cases I did not give the semicolons. Let me give it for you. So now it's done, and now let me print the words. For that, I have to use the print statement once again, and here let me print the words. For that I will write word1 is equal to %s. As I told, for strings it is %s. Then I will use the next line /n. Then again I will write word2 is equal to, similarly I have to write %s. Then I will take the next line command, which is the escape character /n. Then here after this I will give comma, and then I will call my word1 and word2. So this is done, and let me just copy it and paste it here so that I can change it for the word3 and word4. This will be word3 and this will be word4, and here also let me change it word3 and word4. So this is it, guys. This is the total code. Now here I will run it so that I can show you the output. This will actually read a series of words from the terminal using the scanf function. So let me run it, and it says there is an error. Yes, you can see here there is no semicolon, so there is an error. Let me run it once again now, and okay, you can see it's asking me to enter the words one by one. Let me give the words. Let me give the name of our channel, say coders, then arcade. Then we are learning about C programming, right? So let me write C and then programming. So when I press enter, you can see that word1 equal to coders, word2 equal to arcade, word3 equal to C, and word4 equal to programming. So this is how we can read a series of words from the terminal using the scanf function. So here I had given it in different lines. Let me show you what happens if I give all the words in a single line. I will press enter and let me run it once again. The shortcut is F9, and let me zoom it. To zoom it, you should hold the control and scroll the mouse up button. So now let me give the words in a single line. Say I will write the same thing, coders arcade, C programming. And if I press enter now, you can see even if I give the user input in the same line, I'm getting word1 equal to coders, word2 equal to arcade, word3 equal to C, and word4 equal to programming. So it doesn't matter if we give the input in the same line or different lines, it will be stored in the variables word1, word2, word3, and word4. So in this way you can read a series of words from the terminal using the scanf function, as I have shown you in this program. You can see these are the scanf functions that I used. So let me zoom the program for a little bit so that you can see the program code clearly. So this is my entire program code. So this is how you can read a series of characters from a terminal using the scanf function. And here we are using the character data type, and we are using word1, word2, word3, and word4, which are arrays, as variables. So if we take more variables, we can read more number of words.
So hello everyone, welcome to our new video. Today we are going to learn about string and its functions in C language. Okay, so now before starting with strings, is it even necessary to learn about strings in C language? Yes, it is very much necessary, because if you are preparing for any competitive exam or maybe any other type of exams like exams in your colleges in C programming and all, then C is one of the most important because it is a very easy topic and it is also quite small as compared to other topics here. So with that perspective, it becomes very easy to score marks on any type of questions which are asked from the string topics. Okay, so now what are strings? Do we actually have anything called as string in C? Yes. To be specific, we don't have any specific data type called as strings, but it is a character array, a special type of character array which is followed by a null character. We may have a normal character array, but that character array will not have any null character at the last. But if there is any character array which is getting ended by a null character, that means a backslash and a zero, it means that is a string. Okay, so what are strings? It is nothing but it is a sequence, or we may also call it as array of characters which is terminated by a null character. And we have something called as string constants. Now what is a string constant? Any sequence of 0 or more characters enclosed between double quotes, that becomes a string constant here. Now whatever the string we are storing in a character array, now are those characters stored directly? No, those characters are not stored directly. Every character on our keyboard has a specific ASCII value. Now those ASCII values are stored in the binary format in the memory. Now our next thing is, how are we going to declare or define, or how we are going to initialize strings in C language. So here we have 5 different ways. The first one we have is by creating a pointer. I have created a pointer S here which is of the type character. So here we can directly store the entire thing, the entire data, the entire string inside double quotes, and this is done. This is one way. Second way is, instead of star, after the S variable, after the name of the array, give a pair of square brackets. Second one we have, and everything is written inside double quotes here. Another way is, take the same thing, character S followed by square brackets, which is equal to, now here we are storing each and every character. If I don't write this backslash 0 at the last, then this CODERS, here we have 6 different characters which are considered as a character in the array only. It is not a string anymore. But if I am writing a backslash 0 at the last, it means it becomes a string here. Similarly, here I have initialized the size. Here we have not initialized the size. If we are initializing the value in the string variable, then it is not necessary to give the size. But suppose if we are not initializing the value, we are just declaring the string variable, in that case it is very necessary to give the size. Here I have given the size as 10. So even if I have given the size as 10, it is not necessary that I have to give a string of size 10. Here we can also take strings of size less than 10 but not more than 10. But here in these two cases, the second one and the third one, in these two cases, as we have not declared any size, so here we can store strings of any length here. So these are the main things about the declaration and initialization of strings. Next thing comes here is string functions. So here in C language allows us with many string functions depending upon the use that what we want to do. So out of them I have just noted down some string functions here. I have only 16 string functions here right now, and let's just have a look one by one, and also I will be sharing the entire copy of this string functions in the description below. You can just go and have a look there. So here the first one that we have here is strcat. Now what is this strcat? Strcat stands for string concatenation. Here string cat function, it takes 2 parameters and it concatenates both the strings and it stores the entire string into the first string. To be specific, those strings are defined in the string.h header file or the library file. There as the first one is the destination and the second one is the source. So whatever is there in the source string, it is entirely concatenated with the first one, and the entire new data, entire new string, it is stored in the first string after that. So here string cat, it concatenates the second parameter or string at the end of the first one. We have strncat. So now what is this strncat? Now strncat takes three parameters. The first two remains the same as string cat, but the third one is the size, how many characters. So what that actually does, whatever we specify, suppose if I have two characters, let's say coders and arcade, these two are two different strings here. If I'm using string cat, so it will be concatenating everything as coders arcade there. But suppose if I write there only as, suppose this is str1, this is str2, and now while calling this function, suppose if I pass the values as str1, str2, 3. So now it will be concatenating only the first three characters of the second string to the first one, and it is going to make it as coders arc. It is not going to concatenate whatever we have after that. Okay, next one here we have string copy. String copy means whatever is there in the second string, it copies the entire thing to the first one. Okay, string 1, string 2, whatever the data we have in string 2, it copies everything from string 2 and it stores in string 1 by overriding the entire data. After, if we are using this function string copy strcpy, and inside brackets if I pass the values as str1 and str2, so after this function call, string 1 will also be storing there as arcade, and string 2 will also be storing there as arcade. Both will be storing there as arcade. Next, here we have strncpy. So here also it takes three parameters. The third one is a value, that how many characters from the second one are to be copied to the first one. Suppose if I have these two strings here, coders and arcade, and if I am passing here str1, str2, and let's say I am passing the value for n as 3, so this is going to change as arc ers, the first three characters of the string coders cod, they are going to be replaced by arc, and it is going to become here as arcers. Then similarly we have string compare. String compare again takes two parameters. Now it compares both the strings there, that are they same or if they are not same. If they are same, then it returns a 0, and if not, then they might be returning -1 or they might be returning 1. So now what are these different cases? Now if the first string is smaller than the second string, then it returns a -1. It means if the first string has to appear before the second string in the dictionary, or maybe the ASCII value of the first string of any character, ASCII value of any character of the first string is smaller than the ASCII value of any character from the second string, then in that case it is going to return there as -1, or if it is opposite, then it is going to return there as +1. Then we have there strcpy, so string copy I. Now this string copy I, it is case insensitive, it ignores the case of the strings that we are providing with. Then we have str, it returns the index of the first occurrence of second string in first string. Okay, so now similarly here we have strchr and strrchr. In this case of str and strstr, it was taking the second value as strings, the second parameter was strings, and similarly in case of chr, the second parameter will be characters, nothing much, and they will also be returning the same type of values, that the strchr will be returning the index of the first occurrence of the character, and strrchr, it will be returning the index of the last occurrence of any character. Then here we have strlen. From the name itself we can identify this, that it is going to return the length of any given string. Here we have strlwr. It converts the entire string to lowercase. We have strupr, which converts the entire string to uppercase here. Then here we have strduplicate. It creates a duplicate of the string. Here we have stradv, which reverses the entire string. We can use this function to find the reverse of any string, or maybe to find if a given string is a palindrome string or not. And here the last one that I have written here is strcet. This is used to set any given character to the entire string here. Suppose if I write here as coders, and inside this if I give a asterisk here, so my entire this thing will be changed to 6 stars, and I will not be having this data anymore. Now one thing I have left here. Now it is very important to know that what is mutable and immutable, or it is very important to know what is the difference between this one and these 4. Now this first one is immutable, and all these 4 are mutable. It means we can change these 4, but we cannot change the first one. Suppose if I want to change any character, suppose in this case, in case of first one, if I write here as s, and inside square brackets if I write here as 2, so now, and inside this if I write as t, so now in this case what do we think that what is going to happen? Our coders is going to change as COTERS coders, but not. It is not going to fail. It will be giving us a segmentation fault. It won't be happening there. But if we are defining these strings in these 4 ways, then in that case, if we are writing the same statement, then in that case it is actually going to change. So here it is going to change, but here it is not going to change. It won't change if we are defining it as a direct pointer. This is actually a string constant. It becomes a string constant and it is totally immutable. So now let's execute a program and use different string functions, and let's see how do they work. Now let's take some string values and use all those functions that we just did it right now, along with some character functions also, and see how do they work. Okay, hash include stdio.h int main and return 0. So now what we have to do, we have to take 2 strings. So suppose if I write here as str1 equal to coders not int, this will be of character type, and the second one again char str2 is equal to arcade, and it is done. So now as we knew that we can also write it as star str1, right? So now let's just print them and see what do they print. So %s comma str1, and the other one here we have here is str2. Done. So now let's execute them. So here we can see that they are clearly printing here as coders and arcade here, right? So now, as I was saying that these are immutable, So now let's try to change some values here. Let's say str at index 3, str1 at index 3. Let's try to write there as z, and similarly this is a single character, done. And similarly for the second one here, str2, and this is also done. Let's print them. Right here as \n. Now let's execute. So if I execute them, at the first time they are printing here successfully, but at the second time it has not but it was not printed for the second time here. The process has been finished with the exit code some negative number, which should have been finished with the exit code of 0 here. So now if I just comment this line, or let's say if I comment both the lines here, then if I check, it will be working here perfect. Now let's uncomment the second one, and let's see here. For the second one, arcade, at the third index, A has been changed here to Z. It means it has changed successfully. It means it is mutable. Now let's check with the first one, and let's comment the second one. So here again we can see that the process has not finished properly. It is exiting the program forcefully. It is exiting the program here forcefully. So it means it is an immutable. We cannot make any changes for this one, right? So now let's just, so this is it. Now let's make it as an array here and start using all the functions that we have here. So here in C programming we have some functions which are used only with single characters, not with the entire string. Just before this, whatever the functions we looked into, all those functions were directly operated on strings, but there are functions as well which are operated only on characters. So now let's check here. If I am using the function here is alpha, so now it is not giving me any kind of suggestion, and also it is showing red in color. So here, to use these functions, we have to include a file here as ctype.h. Now you can see here that it is not showing any kind of error or no red color here. So now if I write here str1 and any character, let's say character at the index 2, okay, so now this is alpha function, this is going to check, and then it is going to return a boolean value, a true or a false here. So here this is alpha function, it is going to take only one single character as a parameter here, and that is the character at the second index, that is D, str1, and here I have written as 2. So printf, let's write it here as yes, else printf no. I have written here, done. Now if I execute this, we know that here at the index 2 D is an alphabetic character. Execute this and see here it is giving us here as yes. Now the same thing, if I change this to dissect, now if I check, so this time it will be giving us the result here as no, because we don't have any digit here anymore. Now instead of this D, if I change this to let's say 8, so 8 is a digit now, so this time it will be giving us the result as yes. And similarly we have another function here as is alnum, which checks for both alphabetic characters and numeric digits, everything, okay. Execute this, it is again printing here as yes. If I give a space in between, so this time it will be giving us as no, because this is a space, this is neither alphabetic character nor a digit here, done. Then for checking the case, if a given character is in uppercase or lowercase, so we have here E is lower. E is lower, the same element we have D here. This will be a yes, because yes it is in lowercase. Similarly, if I write or if I replace this as 0, it means the first character, which is C. So C is in uppercase. This time it will be printing us here as no, right? Now here we have again something called as 2 upper and 2 lower. Let's say if I remove everything here from here, and if I change here, let's say, so this 2 upper function, it just returns the uppercase of any particular element or any particular character inside the entire string. So here printf, and it is only going to print the uppercase, only just the character. So %c, comma, write here as 2 upper, and inside this pass the character here as str1, and let's say the index 2. So at the index 2 we have here as D. So this D will be printed here in uppercase. So here we have D. So now here these are some character functions. Now let's check some string functions here. Now at first we have here string cat. String cat means string concatenate. Now the string cat functions, they are only available in string.h header files. So we have to include here string.h header file string string.h, done. Now this string cat, as I said, it takes 2 parameters, str1 and str2. It concatenates both the strings and it stores the resultant string into the first string. This is the first string, which is the destination, and this is the source here. Now after this, if I want to print here %d, %s, str1, similarly change this to str2 and \n, done. Execute this. So you can see here the first string entirely it has been changed to as Coders Arcade, and the second one here remains the same. Similarly, as I have told you before, we have one more function similar to this as strncat. This is going to take here 3 parameters, not 2, string 1, string 2, and then the size. Let's say I have written here as 2 here. Okay, now what does this mean? Only 2 characters of the second string of the source string are to be concatenated to the first one, to the destination string. See here, it is only changed as coders AR, not the entire thing. Then the next function after this we have here is string copy strcpy. Now strcpy, it again takes 2 parameters, str1, str2. Whatever values are there in the second one, the entire data gets copied to the previous one here. Execute this. So we can see here the first one is changed here as arcade. Now if we give another parameter here, let's say 4, so only the first 4 characters will be copied here to the previous one, not the entire arcade. So if we change the first 4, so this is going to become as ARCA-RS. So ARCA-RS. Okay, then after this, what we have next? We have here str. So str. Now this str, it takes 2 parameters. The first one, let's say I have given this, and the second one I'm going to give here as er. Now this str, it returns the pointer, it returns the address of the position where this ER is found for the first time. ER is found here at the index third, so it will be returning the pointer, not the index. It will be returning here the pointer, the address where it is found. So here to use this, I will write here printf %d comma, not %d, %s comma, right here, and I will copy this entire thing, or I will cut this entire thing and I will paste it here. So Control X, Control V, give a closing bracket here, and it is done. So now it will be printing this entirely ER, ER and S. Similarly, we have the function strchr. So here we have the function as strchr. Instead of str, we will give here strchr. Now this will be returning, this will be taking only one single character. Let's say here I have given as E. E is found here, so it will be printing everything from here till the last. So execute this. It is working perfect here. Now the same thing, if I write here as strrchr, now in this case it will be returning the last index. Where is it found? It is if I check from the last, E is found here at this index, so at this position, so it will be printing everything from here to the last. So it will only be printing here as ER and S here. See, it is printing here as ER and S. Now suppose if I want to check the length of any particular string, so printf, now length is a integer value, so %d str len, and now inside this pass the string here str1. Now this function strlen, this returns a long integer. So instead of writing d, we have to write here LLU. It means long unsigned integer. LLU stands for long unsigned integer. So here we know that the size here is 6. So execute this. So here it is giving us the size here as 6 here. So now instead of strlen, what if I write here as size of function? What if I am using here the size of function here? This should also give us the size here as 6, right? Because we have 6 characters. But no, in this case size of function, it will be returning here as 7. Why it is returning here as 7? Because it is not a string. Now it is finding the size of the character array, and as we know, if we are considering this as a character array, then in that case we have a \0, a null character at the last. So it is also finding the size of that particular null character also. So total size here, it becomes here as 6 here. Okay. Now suppose if I want to convert everything to lowercase or uppercase, so here we have the functions str lwr and str upr. So here give a comma, write here as str lwr and pass the string here. So now everything here will be converted to the lowercase. Write here as %s. Coders FC was in uppercase, so now everything is converted to lowercase, and not only that particular time when it is printing, but it is also converting everything for the further times also. It means the entire string at the memory itself, it has been changed to lowercase, not only for a particular one time, for every time as we know that it is mutable. So at the memory itself everything is changed. Okay. Instead of writing this, if I only write this statement here without the print statement, str lwr and str1, so it will be converting everything to lowercase. Let's say this time I am writing here as upr. So this time everything will be converted to uppercase here, and now you can see here that everything is converted here to uppercase. And last one, let's check here, reverse, string reverse function. If I am using the function here as strrev and pass the string here str1, so this entire string has been reversed here at the memory itself. Okay, if I write this statement again, if I write this set of statements again, so this time again it will be again reversed to the original one, and you can see here first it was changed to this, and again it is changed to the original one here. So this is about string and its functions, and I have not gone through each and every function because there are a lot of functions. So now if you have any doubts, or if you want us to explain you any specific function, then you can please give us a comment in the comment section. We will definitely get back to you, and thank you for watching the video till the last. If you have liked the video, then please don't forget to press the like button, because that gives us a motivation to make a new video every time. And please subscribe to our channel, and don't forget to press the bell icon so that whenever we upload a new video, you get a notification. So thank you very much. Keep learning. So hello everyone, welcome to our new video. If this is the first video that you are watching on our channel, or even if you have watched videos on our channel before, and if you have not subscribed to our channel, then please do subscribe to our channel, and don't forget to press the bell icon so that you get a notification whenever we are uploading a new video with amazing new contents every time. Okay, so today we are going to discuss about string taxonomy, and it is a very important topic as compared to C language, and it is most preferable if you are studying under VTU, which stands for Visvesvaraya Technological University in Karnataka. So here, what is string taxonomy? This is just a fancy word, taxonomy. It is nothing but it is the different types of classification of strings. Okay, it is just about how we are classifying strings depending upon various different terms. So here I have noted down all the different type of strings that we can have in C language. Okay, the first one we have, the most basic one is character strings, which is nothing but it is a array of characters which is representing a string, nothing else, and it is terminated by a \0. So here we have example, character string I have taken, and hello C I have written here. So this is nothing but it is a string. Then we may also call the same thing as null terminated string, because at the last what do we have? We have a null character over there, which is a \, and a 0. So it is the same thing here again. And then here we have fixed length strings. So now what is a fixed length string? A string whose size is already predefined, which is not changed during the entire execution. Like suppose while declaring a string here, it is obvious that we have to declare it as an character array. So here this character array, it has a fixed size here as 20. If I look at the previous two examples here, they don't have any size given here inside this array, inside this square brackets. So they are not fixed size, but this one is a fixed size, a fixed length array here, which has a size of 20 characters. Okay, then we have variable length string. Normally we can create variable length string in this way also, but suppose if you want to dynamically create a string, in that case we are going to use the malloc function. Now this malloc function, it is taking the size of 30 characters, and then it is, and as we all know that the malloc function, it returns a void pointer, so it will be returning the address, and here we are going to store it in variable length string. And then this, inside this variable length string, this variable here, we are going to store the string here. Okay, and then here we have Unicode strings. Now before that, what is Unicode? simple statement I will say, so that you can understand it better, that what are Unicode. Unicode is a special encoding system which is used to represent all the characters that we have in all the different languages around the world. To represent all those different characters, whatever the languages we have here in the world, Hindi, English, it was already there, so it is also there in Unicode. Along with that, we have English, Assamese, Bengali, Marathi, Tamil, Kannada, Chinese, Japanese, everything, every characters are there. Every characters in all the languages across the world are present there in Unicode. So here, for writing normal characters, the normal characters that we have on our regular keyboard, the total number of characters is uniform. It just needs 1 byte for representing everything. 1 byte here means total, which is equal to 8 bits, which is equal to total 256 characters, different characters. But if we have to consider different characters from different languages, then in that case the number of characters increases. So the size of the character that we are storing there, the size also increases from 1 byte. It may differ from 2, 3, or it may also become 4 bytes there. So for storing those type of values, we need here wide strings. Now how do we store wide strings, or we may also call them as an array of wide characters? Okay, so here we have another type in C which is written as wchar_nt to store wide characters there. Okay, so here we have a string variable wchart Unicode string. Now here this, now as I said that all those characters, they are stored as a wide character. To represent them as a wide character, a capital L has to be written before them. Okay, so this is how we store a Unicode string. C itself does not have built-in Unicode support, but we can use wide characters and wide strings for extended character sets. Then here we have the L prefix that we write in C and C++ language is used to indicate that a string literal is of type wide character. Okay, then next here we have wide strings. Now wide strings, as I have said just now, whenever we have to store some kind of characters whose ASCII value is greater than 1 byte, so for those cases we use a wide string here. Then multi-byte strings. Now here multi-byte strings, to store those Unicodes, they are also called as multi-byte because the size of the byte has increased from 1 byte. It may, as I said, it may be 2 bytes, 3 bytes, or 4 bytes. So they are called as multi-byte because multiple bytes are related there. So these three we can group them as the same one: Unicode strings or wide strings and multi-byte strings. Depending upon the different mode of classification, they are named differently. Here we have literal strings, strings written directly in source code, which are directly written in the source code. Okay, then we have empty strings here, which does not contains anything. They are just only double quotes, and empty double quotes to be specific. Then dynamically allocated strings, the same thing which we did here in number 4, variable length strings. So the same thing has been classified in a different way here as dynamically allocated strings here. Dynamically we are creating a string here, and in that string we are storing some kind of value here. Then we have ASCII strings. Now these are those strings which are using the ASCII character set. Instead of storing the character, we are storing the ASCII values there. So for storing hello, this is how we store hello. Now all these values, they are in hexadecimal format. H is represented as 48, E is 65, L is 6C, 6C we have here twice, O is represented as 6F, and at last, as we know that at the end of the string we have a null character, so that null character, it has a value as 0. So here we have 0, 0 as the value here. Okay, then here we have the hexadecimal strings. It is a string where we have alphanumeric characters which are called as hexadecimal. Okay, then here we have raw strings. Now what are raw strings? Now whenever we are storing the path of any file, okay, or any folder. So the path, whenever we are moving inside a directory, at that junction point we have we have single backslash. Now whenever we are writing a program, a backslash is considered as a escape sequence for null characters, for backslash t which is for tab, backslash n for new line. So backslash x acts as a escape sequence, a special type of character there. So in the path, that might also have a problem. Suppose if I have a folder which is named as t-shirt, which is starting from a T, so that backslash T, it will be acting as a tab character. So it might have a problem there. So for all those cases when we don't want any escape sequence characters to work properly, so there we need, or there we have to consider that as a raw string. So in C language it does not directly support the concept of raw strings, but we can use double quotes to include escape characters literally, okay, when we don't want them to happen. So whenever we are writing any escape sequence, and suppose this is the example, we have a file path here. So in this case we don't want that backslash to act as a special character, escape character. So there in that case we will be using backslash as twice, okay. So this is it. These are some basic classifications of strings, how they are classified depending upon different modes of classifications. So this is all about string taxonomy. I hope you all have understood what is string taxonomy and what are the different types or different classifications of strings. Now if you have liked the video, press the like button, because that gives us a motivation to record a new video every time. And if you have any doubts, give us a comment in the comment section. We will definitely get back to you. Subscribe to our channel and don't forget to press the bell icon so that whenever we upload a new video, you get a notification from our channel. So thank you. This is it. Wish you all a Merry Christmas and keep learning.
Hey guys, welcome to our channel Code is Arcade. This is Ashank David, and in today's video we are going to talk about pointers in C. Now this video is related to all the topics, all the concepts which are there in the VTU latest syllabus which we are following, and in this video we will be covering everything about pointers which is there in your syllabus. So we are going to start by what is pointers, and then we are going to talk about the types of pointers and how we can pass the pointers to the functions. Now let's start. Now before I start with this video guys, I would like to ask you people to please like, share and subscribe to our channel Code is Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Now without any further ado, let's get right in the topic. So we need to first understand what exactly is a pointer. The program that I have written here is to explain you about that as well. So let's understand about first thing, what exactly is a pointer. What exactly is this pointer? So what is pointer? So pointer is also a variable. Pointer is also a variable which holds the address of another variable. So you can see that here I have created a variable. This is how you create a variable int I equals to 50. So now this is a memory location, and you know this, that whenever we create a variable, what is a variable? A variable is a named memory location. When we create a variable, the memory is allocated with some name into our RAM of our system. Now when the memory gets allocated into our RAM, it will have its own address as well, and that type of address could be stored inside a pointer variable. So let us understand about this program here. So first, what was a pointer? Pointer is a variable which holds the address of another variable. So pointer in itself is a variable. It has its own memory allocation also, and it will have its own address as well. So in this case, let's understand about pointers in depth. So this is I have a program to explain you here. I have a program here where I have created a variable int I equals to 15. Now when this variable is created in the computer's memory, this block is created where the name of the memory is I. As you can see, I, and the value is stored 50 inside it. And because it is a named memory location, it will have its own address also. And those addresses looks like this, 0x64FEBC or something like this. This is a hexadecimal value. So addresses of a variable are stored as a hexadecimal value. But if I take an example of hexadecimal values as the addresses in this video, it will get too much complicated. So I don't want to confuse you guys. So rather than this address, I'm going to take some random number 2179. 2179, let's imagine that's the address of this I variable. So now this is a normal variable. This is how your variable looks like when you create the variable for the first time into your memory, into your RAM memory. Now if I want to store its address, what I can do is I can create a pointer variable. So what I can do is here you see in this line number 5, int star ptr. You see this? This is a pointer. This is what? It's a pointer. And what type of pointer it is? Wild pointer. So now we need to understand how this pointer is made. So to create a pointer, usually what do we write is, we first write its data type, so int, then we write the star, and then we write the pointer name. Now there are 3 ways that you can declare a pointer. So first we write the data type, then we write the star, and then we write the name of the pointer. This star can be in between int and this ptr. So there could be some space here also, there could be some space here also. And this is one way of declaring the pointer. Another way is that you can give a data type and then you can just put a star right next to the data type which you have written here. And then after giving some space, you can write this ptr directly here. You understood my point? So now this is another way. Or if you want, what you can do is you can shift this star here, and this is the third way of declaring the pointer. In this example, I have taken the star just next to the name of the pointer, and this is how we declared it. This is one way of declaring the pointer. So you can declare the pointer as you like. So as soon as you declare this pointer right here in this place, what happens in the computer's memory is that another box is created. This another box is created. Why? Because this is another variable in itself which holds the address of another variable. In this case, the name of this memory allocation is ptr. And because it is a variable on itself, it will have its own address also. And just like how we have taken the address as 2179, here we will take the address as some random number 3117, maybe take a random number. Okay. So now in this case, here this ptr is having this address, but this ptr is not holding anything but some garbage value. Some garbage value would be present here. When a garbage value is present inside an empty pointer, a pointer which is declared just, which is not initialized yet, those type of pointers will have some garbage value which make them point towards some random location, and we don't want this to happen. And for that reason only we call them as wild pointer. What is a wild pointer? Pointer which is this declared, it's not initialized. Those type of pointers are called as wild pointers. Now wild pointers should not be there into your program. And to tackle this, we will learn about another type of pointer, that is null pointer, which I am going to tell you about very soon. But in this example, you have to understand that this is a wild pointer. When you just declare a pointer, it becomes a wild pointer. Understood this? Now, because this is a pointer, and in this pointer we have stored nothing here, so it becomes a wild pointer. But in the next step, to clear this off, we need to point it towards the address of some other variable. In this case, we had this variable I, so we stored the address of I into this pointer ptr. So in this case, what happens is that this address 2179 gets stored inside this pointer, and as soon as this happens, this pointer starts pointing towards this value which is stored inside that variable, which is 50 in this case. And this is how pointers work. And this is how you declare a pointer, and pointer is declared, and this is the introduction to the pointers. So this is how pointer works. You can do a lot of things with pointers actually. And if we talk about the types of pointers, usually there are different types of pointers, but in general, there are two major categories of pointers. And what are those categories? Typed pointers and untyped pointers. typed and untyped. Basically, typed pointers are those pointers which will have some data type. Say for example, I created a pointer which is of int type, star int. This will point towards an integer type of value. If I have a pointer of type float, then it will point towards a float type of value. Okay. If I have a pointer which point towards a character type of value, like character type of pointer, it will point towards a character type of value. If we have a class pointer, then it will point towards the class object or the class type of value. Similarly, if I have a structure variable or structure type of pointer, then it will point towards that structure variable in this case. These are typed pointers. So specific type, those pointers which will have its own data types, those are called as typed pointers. Now this is one major category of pointers, typed pointers. On the other hand comes untyped pointers. Untyped pointers are those pointers which will not have any data type. But then what you will write there? You will write void. Void, and then you say star and then ptr. Well, this type of pointer which has the data type as void is also called as untyped pointer, or you can call them as generic pointers in this case. Understood my point? So there are two categories of pointers basically, typed and untyped. Typed pointers will have a data type with them which will allow them to point towards some specific value, but untyped pointers will not allow them. But basically untyped pointers will not have a data type in itself in this case, and that is why it is called as generic pointer or untyped pointers in this case. I hope so that this is very much clear. So how pointers, what are pointers and what are the types of pointers? This is very much clear to us. Now this was just the two major categories of pointers, but actually if I run this program that I have here in this case, as you see that this is the variable I, this is the pointer I have declared, because right now no value is present into it. It is called as wild pointer. Okay, and now I have stored the address. Now this is not any wild pointer anymore. It is just a normal pointer which points towards the address of I, and then I start printing it. Now you see that while I am printing it with %d. That means I want a number out of it, and I am using this star ptr. So when I use star ptr, there are two types of operators we use in pointers generally, that is ampersand and star. This ampersand is called as a referencing operator. Okay, operator. But this star is called as dereferencing operator. What it is called as? Dereferencing operator. And for that reason only, this is what you call as dereference operator. So when you print something like this, I want this access specifier as %d, which means number in this case, and it will dereference this pointer, means it will decipher the address of this pointer and it will give us the value. So this should print 50 in this case. And if I run this program right here, if I run this program right now, you can see that it will print 50 directly. You can see that it prints 50 in this case. So I hope that this is very much clear to everyone, right? Now we will see what are the different types of pointer. Now I told you that there are two categories of pointer, typed pointers and untyped pointers, but there are many different types of pointers basically. So we have wild pointers, then we have null pointers, null ptr, then we have dangling pointers, then we have double pointers, and today we will also see some working of void pointers as well, that is generic pointers. Okay, so let us cover all these topics in this video. Okay, so now the very first one is going to be wild pointer. You have understood, this is the wild pointer, basically a pointer which is not initialized, it is just declared. That is what you call as a wild pointer, and that's all you need to know. Wild pointer should not be available in wild pointer should not be there into your program, otherwise it will point to some random location which is actually existing, but it will point to some random location which is not good in this case. So while pointer should not be present, and that is the reason why either you should allocate a memory, either you should allocate the address, or you should allocate it to null. And which brings us to our next pointer, and that is called as null pointer, right? So what is null pointer? When you have a pointer and when you initialize that pointer to null value, null, capital NULL, now this has become a null pointer in this case. So what it has become? This has become a null pointer in this case, right? So now why do we use null pointer? Null pointer is used to just deallocate or point a particular pointer which is pointing towards some random location to some particular null value. Usually null value means 0 in this case. Well, null is not a particular value, but when you want to just keep some random address, when any particular pointer point towards some random memory location, like for example while pointer, you will have to initialize it to null, otherwise it will point to some random location and you won't know where it is going to store what. And for that reason only we use null pointers. But you see one thing here, that in this program I have written null pointer, I have declared a pointer here int star ptr and equals to, when I say null, if I try to print this, it will just say 0, it will not say anything in this case, because here I have given, you see, I'll run this program and I'll show you. See, when I run this program, what it says, it doesn't have anything. So basically this is undefined reference. This is what you call as undefined behavior into your program. And we don't know how our program will work. So in this case, what we will do, see, I have written it here for you. This code will likely result in an undefined behavior and the specific consequences can vary. The program might crash, produce an unpredictable output or behavior in an unexpected way. Undefined behavior means that the C standard does not specify the outcome and it is up to the compiler or the runtime. To avoid these situations, it is crucial to check if the pointer is a null before attempting to dereference it. And for that reason, I have written another program here. You see, in this case, when a pointer is null, you will check if the pointer is not equals to null, then you will print the pointer. Otherwise, you can just print the pointer is null. So basically, what did we learn from this is that null pointer is used whenever we want to point a pointer which is pointing to some random location with a null value. You don't want any pointer to point some random location. For that reason, to neutralize that pointer, we use null pointer. I hope so that this is also very much clear to everyone, right? So this was basic pointers. This is null pointers. There are two types of pointers I've already covered. Now the third one is going to be double pointers. Now you see I've written another program here for you to understand, and you see here one thing, that here I have created, so what, first of all we need to understand what exactly is double pointer. Double pointer is another type of pointer which we are going to understand. So in this case, what happens is, what is double pointer? So double pointer is a pointer. So we say double pointer. Double pointer. Double pointer is a pointer which points towards some another pointer in itself, basically. So basically, what is this? Say suppose this is a variable that you have created. So this is that I that you have created, and this has this value 50 in it. It will have some own address like this, and you have created another pointer in this case, you see, and that pointer is this pointer ptr. This one is single star ptr, and this pointer is holding the address of this pointer, which means 2179 is pointing is stored inside this pointer, which is actually pointing towards this value. Let's say this address is 3179. So when you put more stars, when you increase the number of stars, that becomes a double pointer. And double pointer is actually used to store the address of another pointer. A single star pointer will point towards a normal variable, while a double star pointer will point towards a single star pointer. So basically when you want to store the address of a pointer in itself, that will be done by a double pointer. So double pointer is a pointer which holds the address of another pointer in itself, which allows us to dereference that particular pointer multiple times. So you see here, I can create another pointer now with double star dptr, and I can say, let's say it has 4178 value as an address. So in this case, what happens is that if I store this 3179, this double star pointer will start pointing towards this single star pointer, and this is going to point here. So when I'm printing it, you see, when I'm printing it, I'm saying %d as the access format specifier, and when I say double star dptr, star means dereferencing, right? So single star means I am dereferencing this pointer one time, which will give me the value 50. But if I dereference this pointer 2 times, it will again give me the value 50, because you see, this pointer is holding the address of this pointer is holding the address of this. If I dereference this dptr once, it will only give me the address of single star ptr. And for that reason only, we use double pointers. Basically, double pointers are going to be a concept which is going to be used in data structures, and we will be using it a lot later on. Okay. So now if you see this example which I have written here, we will talk about this. Let's run this program and see. You can see that I have created a variable here, I equals to 50. Then we have created this star ptr here, and then this star ptr, then we have created 2 star ptr, and then we have created 3 star ptr, and then I have created the I have initialized this ptr to ampersand of I, dptr to ampersand of ptr, this ptr, double star ptr to ampersand of ptr, and then double star ptr, triple star ptr pointing towards the double star ptr in this case. And in this case, what happens is that we are just trying to dereference the pointers one by one. So single star, double star and triple star pointers we are dereferencing. So in this case, when I run this program, it will all print 50, 50, 50, 50, 50, 50, because here you see this is single star, double star, triple star pointers in this case, right? If I change this, let's say if I change this to a double star, then what will happen is when I save it and when I run this, you see that it will give me the address of the previous pointer, because we are only dereferencing it 2 times in this case. So for that reason, we need to give more stars in this case, and when we run it, you see that it tells you about the values there. I hope so that this is very much clear. So this is your double pointers. And now in next type of pointers, we are going to talk about dangling pointers. Okay. So what are dangling pointers? So first of all, you have understood the concept of pointers. See, pointers are the variables which holds the address of another variable. So when you hold the address of another variable, it starts pointing towards the another type of memory location. Double pointer is a pointer which holds the address of another pointer, basically. So we have understood about that also. What is dangling pointer then? A pointer which points towards a memory location which is not even existing now. That means at some point of time, you have allocated some memory to this pointer which you have created, and then you have freed that memory. And when you freed up that memory, what happened is that it started pointing towards some random memory allocation. And that is what we call as dangling pointer. A dangling pointer is a concept which your program should not contain in any scenario. And for that reason only, we should know how to handle it. And to handle these dangling pointers are not good into your program. And to handle this dangling pointers, we need to initialize it to null pointer, as we have understood that null pointers are used to neutralize the pointers which holds the address of some random memory location or the non-existing memory location in this case. So this is another type of pointer, guys. And you see that here I have started by creating a pointer, and in this case we are dynamically allocating the memory here using the malloc function. And here I have said int star, so this is typecasting. So whenever you allocate the memory to a particular pointer, it returns you a void space, and that void space has to be typecasted into that type of value or that type of memory. And to do that, we use typecasting. So we will typecast that into that type of pointer, means integer type of pointer. We will typecast that into that type of value, and then we will give that. So this is your dynamic memory allocation. So I have dynamically allocated the memory to that pointer, and then I have printed that pointer. So in this case, it will print some random locations. If I run this code right now, So basically when I run this code right now, you see it is just printing some address which it is storing in this case. Okay. Now you see that after allocating the memory, I'm using free function and freeing up the pointer. In this case, what happened? When I said free PTR, the pointer which was pointing towards some random memory location, now the memory is freed up. So what happened is that this pointer started pointing towards some random memory location, and for that reason it became a dangling pointer. So a dangling pointer is a pointer which will start pointing towards some random memory location. Not random memory location, but a non-existing memory location. When we are talking about random memory allocation, then it will become a wild pointer. So that is the difference between wild and a dangling pointer. A wild pointer will point towards some random memory location, while the dangling pointer will point towards the non-existing memory allocation in this case. So you should not have that dangling pointer into your program. And to dissolve this condition, we need to make it as a null pointer, hence assigning null value to a pointer, making it a null pointer. This will solve your issue. And at last, you see that when I run this, it prints 0 at last. Yes or no? Right? So in this case, this is how we are explaining you the dangling pointer like this. So basically, ultimately, in a nutshell, dangling pointer is a pointer which is pointing towards some random non-existing memory location. The memory location is not even there, but still this pointer is pointing towards some non-existing place, and for that reason it is called as dangling pointer. To achieve dangling pointer, in this program we have allocated the memory and then we have deallocated the memory using free, and then we have just, to make it a normal pointer, we initialize it as null pointer in this case. Well, I hope that it is very much clear to all of you. This is the third type of pointer. So first one was wild pointer, second one was null pointer, third one is dangling pointer, and fourth one was double pointer. So there are 4 types of pointers which we have already covered. Now in this program, in this video, let us talk about the last type of pointer, and that is void type of pointer. So just now I have explained you that void type of pointers are also called as generic pointers or untyped pointers. Now void type of pointers advantage is that you can point this particular pointer towards any type of value. Basically, you don't have to give the data type, you just say void. It can store any type of address. It may be an integer variable address, or it may be a float variable address, or it may be a character variable address, or anything. Well, to use this pointer, what we do is we define it like void star PTR, and then we say, for example, in this example program only, I am saying void star PTR. So this is void pointer declaration. Okay, so you just write void and then star and then PTR. Okay, and then what you do is you say int, I have created another pointer, so int star PTR1. So I am declaring the integer pointer. Then I have another data, which is a normal variable, int data equals to 10. So basically this is integer variable initialization, and then what I am doing is I am storing the address of this data into this integer type of pointer. So what I have done here is that I have stored the address of this data inside this pointer, okay, this PTR1 that you are seeing here. Okay, and now we are trying to allocate, so we are assigning the void pointer to the integer pointer. And how to do that? We are typecasting that pointer inside this PTR1, and this way we will be able to do the we are assigning the void pointer to the integer pointer. So we first, because this is a what? This is a void type of pointer, it will have a void type of memory allocation. You need to typecast it before you put it inside this PTR. So this PTR1 will now be stored inside this PTR. And then if I print the value of PTR1, it will be printed as You see 10. I hope so that it is very much clear to all of you, because the data was 10 in this case. Well, I hope so it is very much clear. This is your void pointers, and this is how you work with it. Now the last concept of this whole topic, pointers, is passing the pointers to a function. Basically, we can achieve it by doing call by reference and call by value also, and in this case we will learn two things: how you can pass a pointer inside a function and how you can do call by value and call by reference. Now let us understand about this here in this video. So first of all, we have a call by value. In this case, when you have a function, say for example in this program, what I have done is, in the main function I have created two variables, int a equals to 10 and b equals to 20. So a is 10 and b is 20. Okay, and then I have created a function here which is doing the swapping part. We all know how to swap. We use a temp variable, store a inside it, and then we use b inside a and then temp back to b. This way the swapping will happen using the third variable temp. Now in this case, I printed first in the main function, I printed before swapping a equals to this and b equals to this, and printed the a and b value respectively. Then I have called this function right here and I have passed the a and b. So 10 and 20 are passed. And then later on, after the function is called, I am printing after swapping the same thing. You see, when I run this program, what happens is that there is no swapping occurring. There is no swapping happening. So a equals to 10, b equals to 20, a equals to 10, b equals to 20, still after swapping and before swapping it is the same. Why this is happening is because, now this is something which is related to functions. If you don't know about functions, we have created a whole video on what exactly is function in our previous modules. So please go ahead and watch those videos first and then come back to this video and you will understand about this. But if you are new to this video, if I want to explain you in short what exactly is a function, function is a block of code which holds the does the specific task whatever it is assigned to, and whenever you call it to do so, and that will do the job. So in this case, this function is doing the part of swapping, and the return type of this function is void. So it will not return any value back, and anyways you cannot return two values at a time from a function. And for that reason only, what we have done here is that because this is a void type of function, this function cannot tell the main function back that it has made the swapping changes. So what it will do is that it will not tell. It is actually, if you see, if I print this after swap right here in this function, it will actually print that it has been swapped, but actually it has not been swapped for the main function. In the main function, still a and b are still a and b like that only. And why? Because while I was calling that function, I have just passed the values. This is called as call by value. In call by value, what happens is that generally whenever you pass any data directly to a variable inside the function parameters, the changes made by that particular void function is not returned back to the main function, and hence the changes made by the void type of function doesn't get reflected back to the main function. I hope so it is very much clear. Now if I go back to call by reference, in call by reference, in the same program we are just using pointers, and now in this example actually I will show you how you will pass pointers inside a variable, inside a function. So I have created a function here called as void swap, and you can see that as a parameter only I have passed two pointers, int star a and int star b. So these are the 2 pointers which are passed into the function parameters. And now actually I am doing the swapping using those pointers. So basically what I did is I am using the third variable temp, and I am swapping the pointers in itself, not the value, just the pointers. So the whole pointer in itself is swapped. Okay. In the main function, I said a equals to 10 and b equals to 20, and I said printed before swapping a equals to this and b equals to this. And then I called that function, and because they are the pointers, in the call of that function, you will give the ampersand of the address of a and address of b. Well, I hope so this is very much clear, that whenever you give the pointers as a parameter of a function, in the arguments you will pass the address of the variables in this case, in simple terms, because this parameter will only hold the address, not the normal value. So you cannot just pass a, you have to say ampersand a, and for that reason only I am passing two things, ampersand a and ampersand b, and then I am just printing after swapping. Okay, so in this case what will be the result? It will just swap the two numbers. Before swapping 10 and 20, after swapping 20 and 10. Well, this is your call by reference. Well, I hope so that this is very much clear to all of us, right? If you have not understood the concept of call by value and call by reference, we have another video which I have already created, and I have explained everything about that in another video. So if you haven't watched that video, I will give the link of that video in the description as well as in the I button up there, and you can go ahead and watch that video as well. Okay, as of for now, these are the topics which we had to cover, and this is what is pointer is. So pointer is what? It's a variable. So this was the program that we saw. So pointer program. So pointer is a variable which holds the address of another variable. Then this is null pointer. Null pointer is used to neutralize any pointer which is pointing towards some random location or a non-existing memory location. Double pointers are the pointers which holds the address of another pointers in itself. And dangling pointers are the pointers which point towards some non-existing memory location. Wild pointers, on the other hand, are the pointers which are non-initialized. They are just declared. That means they will have some garbage value inside it, which means they will point towards some random memory allocation, right? And then void type of pointers at last. So void type of pointer can point towards any type of pointer value basically. And at last we have done call by reference, where we have understood how you can pass the pointers inside the functions parameters and how you can use them, and we have understood about the call by reference also with this case. So in this case where we are calling the function, we pass the reference and the reference goes into the pointers as the parameters. Well, I hope so that this video is very much clear to all of you, and this way we have covered the syllabus for VTU scheme, the latest scheme that we were working on, and this is the pointers concept. I hope so that you have liked this video. If you have liked this video, tell us in the comment section below. If you have any doubts, tell us in that comment section below as well. And don't forget to press the like, share and subscribe button. And don't forget to press the bell icon so that you won't miss any future updates. And share this video to your friends and family. And that's all for this video. This is Ashank David signing off. I'll see you guys in the next one. Peace.